Okay, so in starting with problem 92, create multiple representations, table, graph, and equation for the function g of x equals 2 over x, then write or make 3 summary statements. So summary statements is what we worked on in class. So we have 2 over x is our function. So we're going to go in our graphing calculator and delete that. And 2 divided by x. Nothing else in there, so we don't need parentheses or anything crazy. It's still going to give us that double swoop thing that we saw in class last time, which is called rational. So then what we're going to do is we're going to draw the table and the graph onto our papers using this guy. So then our graph go by ones again. It's nothing perfect, so it's going to go up this way and go that way, and then go this way and go down. So remember, when it says complete graph, you're going to take your time and go through all of the things I've been doing on graph paper. But for this one, I'm just going to give you a quick idea because there's so many right answers for the summary statements. So for this one, you just go into the table, copy down as much or as little as you think. I would get the -4 and kind of get all of this to see this shape, and then also show this shape. And then we have an error in the middle, so I would make sure I have that one too. So I'm going to go -4 and -1/2, -3 and 2/3, -2, -1, -1, -2. There's my error, or that asymptote we talked about, because you can't have a 0 in the denominator there, so that's why it has that jump from one to the other. Then +1 is +2, 2 is 1, and then 3 is the same coordinates, just positive. So this guy is in a mirror image of that one. It's just because of the asymptote, it has to jump like that. So in your summary statements, make sure you have a statement that answers one of those questions from the slides. If you want to use any of those, you can. And then make sure you justify within the graph, show a complete graph and write about it. And then in the table, same thing, make sure you have the table copied down and show the math behind the table, and then justify within the equation. So there are so many different right answers here, I can't go through all of them, but make sure you have that kind of skeleton set up, and all of those resources were in the Google Classroom for 122 if you need to look back at any of them from class. So then 93 says, suppose you want to find where the lines y equals 3x plus 15 and 3 minus 3x cross, and you want to be more accurate than the graphing calculator or graph paper will allow. You can use algebra to find the point of intersection. So then part A says, if you remember how to do this, find the point of intersection using algebra and be prepared to explain your method to your team tomorrow. Obviously, we're not doing that. If you do not remember, then do parts B through E. So B through E walk you through what I'm going to show you. So we're just going to do part A. So part A says we have 3x plus 15 and we have 3 minus 3x. So we have these two lines, which we know this one's going to start at 15 and go up this way somehow, and this one's starting at 3 and going down this way somehow. So the question is, where do those two intersect? And again, intersect means crisscross. Crisscross means they meet. If two things meet, then they are the same thing. So if they are the same means equal in math, so you can just set them equal to each other and solve them. So you don't have to overthink it. Remember what it means to be an intersection, and then just solve for x. So I'm going to add 3x to both sides. Subtract 15 from both sides. And then divide both sides by 6. So I know the x coordinate for where they intersect is going to be -2. So if I'm looking at this, somewhere at -2, somewhere over here, these two lines are going to be crisscrossing each other. So the question is, how far up or how far down does that intersection occur? So I'm going to plug this in as my input. So my input now for this equation, again, doesn't matter which one, they'll both give you the same answer. So plug it into one of them. So when I plug -2 into the function, -6 plus 15, my answer is going to be 9. So my intersection coordinate is -2, 9. My input of -2 that I solved for found me an output or a y coordinate of 9. So remember, y equals is the same thing as f of x, g of x, h of x. They're all the same thing. So you can use them interchangeably. That is also what B through E was going over, all of that just step by step, but we can just roll with that. And then we got 94. The Salami and More Deli sells a 5-foot submarine sandwich for parties. It weighs 8 pounds. Assuming that the weight per foot is constant, what would the length of a 12-pound sandwich be? So, wow, it's a 12-pound sandwich, geez. So when it says that it's constant, that means they are proportional. So if one is 5 foot and 8 pounds, you can proportionally set up another ratio. So if I have 5 feet gives me an 8-pound sandwich, the question is, how many feet will a 12-pound sandwich give me? So it's really just making a proportion. Don't overthink that. Since it says it's a per foot constant, that means it's a ratio or a proportion. So now you can just cross multiply. And when I cross multiply, that's when I start dropping my labels and just focusing on the numbers, and then I'll put the labels back in. So I have 5 times 12 and 8 times x. Again, just taking out the context clues and just using the math for right now, and then we'll put them back. So then 60 equals 8x. Divide both sides by 8, and you get 7.5 as x. So now I can put it back into context to give me a more precise answer. So it's 7.5 feet. It's a big, big sandwich. Okay. A couple more. So number 95 says if h of x is x squared minus 5, where does the graph of h of x cross the x-axis? Make a sketch. So h of x is x squared minus 5. Oops. So x to the second minus 5. Let's take a look at what this looks like. Should be a parabola. Yep, because it's x squared. So we should have that little idea in our heads when it pops up. We know if we type something in right. And it says we can make a sketch. So when I look at this, I can see that those points aren't perfect, but this vertex down here is. So I'm going to go to the table to see if I can see what it is better. So it's at 0, negative 5. And then if I go back to the graph, I don't know exactly where it crisscrosses. I can see it goes in between 2 and 3, so somewhere over here. It says sketch, so I'm allowed to be inaccurate. And then again, a little past 2 on this side. So I'm just going to sketch that guy in there. Again, just eyeballing. Sorry, I'm not an artist. But then the question does say, where does it cross the x-axis? So if it's crossing the x-axis, that means x-intercept. We've already done this 6 times. So x-intercept is what when y is 0. So again, plugging y in for 0 and solving the math. So instead of h of x, remember it's the same thing, so I'm going to replace that with a y. This and this are the exact same thing, just different ways of writing it. So 0 equals x squared minus 5. Add 5 to both sides. And undo with a squared. Now, if you just said the square root of 5, which if you type that in the calculator, the square root of 5 is approximately 2.36. You'd only get this one. So you would think the graph looked like this. But it's a parabola. It has 2 sides. That's why in Algebra 2 you have to be very careful, because a minor mistake, like dropping a plus-minus symbol, means you're forgetting half the picture. You only saw the positive half. There's a whole other piece of that parabola there. So make sure you're very careful. I know it seems silly, but that little detail makes a big difference. So it crosses at the square root of 5, 0, and the negative square root of 5, 0. So those are our 2 intercepts, which is what the question asked for. So then 96, graph the following equations. So part A says y minus 2x equals 3. Well, I can't graph that in my calculator unless it's y equals, so I'm going to add the 2x to the other side. So now I have the y equals key, or I can use the y equals key. So we have 3 plus 2x. So starting up at 3, my slope is 2-ish. That. And then part B says make a sketch. Again, I can't hit the y equals key because I have the -3 on this side. So if I want to use the graphing calculator and not manually enter things into a table and manually do it all, I have to move the 3. So I'm going to add 3 to both sides. So now I have the y equals, so now I can type in that key. So then x squared plus 3. So it should be a parabola if I did it right. Bada bing. Starting up at 3 and heading up in a positive direction. Nothing fancy, just getting the graph down. But now it says state the x and y intercepts for each. So I'm just going to put them right on the graph. So the intercept for this guy is, 0, 3, and then that intercept was so this x-intercept is not a whole number, so I have to do some math. So again, plugging in the 0, subtracting 3 from both sides, dividing by 2, which if you want to look at it is -1.5. So that point's really more like right there. So -1.50. This guy, his y-intercept is right there as well. It is also 0, 3. And then for x-intercept for this one, where does it cross this x-axis? It doesn't. So then your x-intercepts are none. Don't leave it blank, write none. So it doesn't look like you skipped it or missed it or didn't know what to do. You knew the answer was none. And then it says, where do the two graphs cross? Show you how you can find the points of intersection. So when we're looking at that, we can do it mathematically, practice our algebra, because we're trying to figure out where do these two cross. So where do they meet? So where do they equal? And since we have them both in y equals form right here, that's the forms that we would use to set them equal to each other. So it would be 3 plus 2x equals x squared plus 3. If you have them both in the same form, you can just set them equal to each other. You can't set these guys equal to each other because there's different stuff on both sides. So you'd have to get something that has something common. So then now I can subtract and get everything over. It's an x squared. So I know I'm going to have to factor or do something of the sort. So when I'm going through it, I just have to go very carefully. So then minus 2x minus 3 minus 2x minus 3. So I have minus 2x and then plus 0. So I have x squared minus 2x. So now I can factor it. So I can take an x out of both of them. So I have x equals 0. And then solve. So then I know they intersect when x is 0 and when x is 2. So this is just taking the GCF and then figuring out what those x values are. And again, that's the x values for where they intersect. So I'm going to plug them in individually. So I'm going to do f of 0 first. Doesn't matter which one you want to plug it into. I'm just going to pick this one because it's linear. So when I get f of 0 here, I get 3 plus 0 is 3. So one of my intersections is 3, 0. And then I plug the 2 in. Again, any equation you want. I'm just going to use the linear one because it's easier for me to do in my head. So 3 plus 4 is 7. So my intersection here is 2, 7. I'll write it nice and neat over here. So intersections are 0, 3 and 2, 7. So that was a big problem. Started with graphing them individually, looking at their common intercepts and different ways of finding intercepts, and then looking at how to find the intersection. So we got one more problem, and we're done. The last problem is number 97. This is all geometry review / algebra 1 review. So it wanted you to figure out what each of the equations are. So I'm just going to write them all out and then just put their names next to them. So the first one is that is the quadratic, which was option number 4. And then part B said sine of A over little a equals sine of B over little b. That is geometry. This is algebra 1. This is geometry. It's called law of sines. That was option number 2. Got some more geometry. C squared equals a squared plus b squared. That's Pythagorean. And that was option number 3. Sorry, that's Pythagorean theorem. I started to run out of space. And then the last one then, process of elimination, or if you remembered this one, that is called the law of cosines. Law of cosines was number 1. So algebra 1, geometry, geometry, geometry. All things we will be using at one point or another in algebra 2 at some point. So if you have any questions on any of those, let us know. And that is the rest of this homework assignment.